In this video I'm going to go through question 3 on the Math 2007 paper. So in this question we're told that IC is equal to this integral where C is a real number. And for part 1 we're asked to sketch x minus 1 squared plus 1 for x between minus 1 and 3. And then to indicate on our graph the area represented by the integral I1. Okay, so this graph that we're trying to draw is just like a normal x squared graph, but we're translating by 1 to the right and then 1 upwards. So if we draw the normal x squared, this is just y equal to x squared. Then if we translate to the right, because we've got the minus 1 inside the brackets there, and then because we have plus 1 on the end, we're translating 1 up. And so our final graph for x minus 1 squared plus 1 would look like this. And as for the area represented by I1, that's just the integral of this between 0 and 1. So if that's 1, then this area would just be everything under the curve up to 1. And for part 2, they want us to explain why IC is greater than or equal to 0 for any value of C without explicitly calculating IC. Okay, so let's have a look at our integral. If we look at what we're actually integrating, then we see that this x minus c squared plus c squared, well, those are two squared terms, and so they will be greater than or equal to 0. So the function that we're integrating is always greater than or equal to 0, and so it's always going to lie above the x-axis, and so the area that we're looking at is always going to lie above the x-axis, and therefore our integral is going to be greater than or equal to 0. Okay, and now they just want us to calculate IC, so they want us to do this integral. So there's nothing special about this integral, we're just treating C like a number. So why don't you pause the video and try it, and then I'll talk you through it. Okay, so first, if we expand out this bracket inside the integral, then we get x squared minus 2cx plus c squared, and then I collected the two c squared terms together. And now if we just integrate this with respect to x, so the x squared will go to a third x cubed, and the 2cx will go to cx squared, and 2c squared will just go to 2c squared x. And so if we substitute the limits in, then this is what we get when we substitute 1 in, and when we substitute 0 in, then everything's just going to be 0. And so this is the answer we get for our integral. Okay, and for part 4, it asks, what is the minimum value of IC as C varies? So remember in the last part, we just worked out that this is IC. So we just want to find the minimum of this. So I'm going to do that by differentiating. So when we differentiate IC, we get 4c minus 1. And then if we set the derivative to 0, we get that c is equal to a quarter. So the minimum is going to occur when c is a quarter. So if we substitute that into IC, and if we just simplify and calculate the right-hand side, we see that the value of I a quarter that we get is 5 over 24. Okay, and for part 5, they want to know what is the maximum value of I sine theta as theta varies. So remember, this is what we worked out IC was. So now our C has become sine theta. And we know that sine theta lies between minus 1 and 1. So we're looking at IC when C is between minus 1 and 1. So if we look at the graph of IC for C between minus 1 and 1, so IC is a quadratic in C, so it's going to have this shape like a parabola. And in the last part, we worked out that it had its minimum at a quarter. And so if we look at this graph of IC between 1 and minus 1, we see that it's highest at minus 1, which is the value of C that's furthest from a quarter. And this makes sense if we look at it in terms of sine theta as well. So I sine theta is going to be 2 sine squared theta minus sine theta plus a third. And we know that sine squared theta has a maximum value of 1, and sine theta lies between -1 and 1, and so minus sine theta is going to have its maximum at 1 when sine theta is equal to -1. So when c is -1, i.e. sine theta is -1, we see that this minus sine theta term has its maximum, and also sine squared theta would be 1, so sine squared theta would be at its maximum too. So it makes sense for I sine theta to be maximized when sine theta is -1. So if we substitute -1 into IC to work out the value of this maximum, then we see that it's equal to 10/3.